All right. So we'll come back to this in a little bit. I want to take you guys all the way through one of these. So I'm going to let you guys read this real quick, so we're all on the same page. Oh, we're not going to get through this. We'll get through some of this, though. I just saw what time it was.
Can I steal someone then, since you're not getting all the way through it?
Yeah.
Thank you. So, can I steal?
Guys, I thought he was spying on me for a second. Okay. So let's maybe just do that first box of this. Is that cool? All right, so we are going to do a 1 sample T interval for mu. And mu is equal to the true mean screen tension. Does this feel good so far? Let's start with random. Oh. Are you suspended?
Yes.
Yeah, I figured as much. Everybody good? All right. Now, looking at these, our sample size is not greater than or equal to 30. So, what do?
Check if,
We're going to sketch a quick box plot, or dot plot, excuse me. Okay, so these are going to be screen tensions. Hey guys, even though I have an example problem, I know nothing about what this problem is saying. And that's okay. And let's see, my lowest one is 234. My highest one is 343. So I'm going to go ahead and have this go from 225 to 350. 250, 275, 300, 325. Did I do that right?
2.
Okay. And I'm just going to go through and put, there's 270, 297, 270, 283.
What's it go up by?
It's going up by 25s. 305, 280, 257, 318, 327, 265, 308, 310, 343. All right, so we've sketched our graph, and what do we see here? Are you guys cool with saying that there's no major skewness or outliers here? And then independent, we're going to say 14 is less than 10% of all screens. All right, so on Wednesday, we'll start off with actually running through this and get some practice with these. Okay, so so just like we said, hey, we're trying to make an estimate. Another hint is it says construct and interpret a confidence interval. So we're going to do a one sample t interval. It's no longer a z interval, so when it's means, we typically use t instead of mu. All right, now, and then we went through and we checked our conditions. The random condition is how we've always checked it. The independent condition is how we've always checked it. The normal condition is now either going to be n greater than or equal to 30, or if it's not greater than or equal to 30, we can at least assume our sample came from a good, mostly symmetric population. We do that by looking at the sample and say, is it reasonable to assume the x bars will still be normally distributed? So we had to draw a graph, and we said there's no major skewness or outliers. All right, so the next thing we have to do is our actual calculation. So a reminder that the calculation of this interval is done by doing x bar plus or minus t star times s over the square root of n. Now, can we find any of these pieces of information right now? We know that n is equal to 14. Sweet. And once we know n, can we find t star? We draw a little normal curve with a mean of 0. How many degrees of freedom do we have, y'all? 13. We just take our sample size minus 1. Okay? 90% confidence means we want the middle 90% of our x bars. What does that make the area of the tails? 0.05. 0.05. Then we use inverse t. What do we get?
1.77. Or plus or minus, but that's kind of...
That t star equals plus or minus 1.77. Sweet. Okay? All right. So now, the other pieces of information we need are, we need to find the mean and the standard deviation, yes? Does anybody remember how we can find the mean and the standard deviation of a set of data?
You just add them all up.
Well, that helps us with the mean, for sure. Except for that's not going to help us with the standard deviation.
Standard deviation would be the 0 mean and 1 standard deviation normal distribution.
So if we wanted to do the standard deviation by hand, what we would have to do is find the mean, figure out how far is each point from the mean, square that distance, add them all up, divide by n minus 1, and then take the square root of our answer. Or how about we type these in for L1? A reminder that the way we do that is you hit stat and then edit. She's so loud. I legit heard her laugh in Dr. Lee's room this morning. She was by the front door of the school.
You're welcome.
Okay, do you guys remember how to find the mean and standard deviation from there? You're going to hit stat, arrow over to calc, choose the one variable stats. It should be your first choice. Make sure your frequency list is completely blank.
Didn't like what I did.
It didn't like what you did?
Did you get rid of the L2 and the,
Oh, I see the issue. Okay.
I want to say the mean was like 290.5.
yeah, exactly.
And then I can't remember what the standard deviation was.
Is it S or
S.
It should be
S.
because it's
30.07?
30.07. Okay. So, from there, if you want to build your interval, you would say 290.5 plus or minus. Your T star was 1.77. We just found S to be 30.07. Divided by the square root of your sample size is the square root of 14. Is everybody with me?
Could you zoom in a little bit?
You mean like that? Everybody good? Hey, what do we get? Can someone do the minus and someone do the plus? You did the minus, Nina?
276.28
Okay.
to 304.72.
Nice.
Is there a better way, like, is there a way to get the standard, like, the exact standard deviation from that list? Because I couldn't actually, like, get up to that.
What do you mean?
Like, cause, mine are rounded different, so it's like 0.27 instead.
That won't be a big deal. That's not a big deal at all.
She said nothing.
Alright.
I think she meant like nothing in the plot.
Is everybody okay? All right. What do you guys think? Is this okay? I'm just typing in the calculator. Now, that being said, I know it will shock you that your calculator has a shortcut to do T intervals. Now, why do you guys think I made you guys do this by hand once?
So we know how it works.
Not just so you know how it works, I want you guys to think back to your most recent test, the multiple choice questions. The very first two have formulas filled in. They didn't actually give you the answers. Do you guys see what I'm saying? So I want you guys to kind of get a feel for how we build these, even though you're not going to do them by hand if asked. Okay? All right. So, guys, go ahead and hit stat and arrow over to tests, just like we would go find any of our other tests. Of course, I don't have these in. All right. Alright, 283, 305. Okay. There we go. All right. So if I go to stat, I arrow over to tests. This time, what are we doing? We're doing a one sample t interval. So I'm going to go down and choose. If I look at choice 8, it says t interval. Okay. So we're going to do a t interval. If this is the case, the first one we're going to do is let's go ahead and assume. Well, what we have is we have the data entered in our calculator, so I want you guys to go ahead and make sure data is highlighted. All right. The list where we put our data is L1. If you ended up putting yours in like a different list, you might want to put in a different list, okay? Confidence level in this case is 0.9, so we're doing 90%. We go down, we hit calculate.
Is it okay that frequency says 1?
The frequency should say 1.
Okay.
If it defaults to 1, good. If it doesn't, so like sometimes it wants you to leave it completely blank, sometimes it wants a 1 in there. If you try to do it completely blank and it does nothing, like it won't let you do it, just put a 1. Okay, is everybody good? And you can see we got slightly different answers because of rounding, but it gives you the interval. It also gives you X bar, S, and N, so you want to make sure you have those written down somewhere in the calculations box. So basically, your rule of thumb should be in terms of what do I need to write down. If you have to tell it to the calculator, or the calculator gives it back to you, that means it's important information that you need to make note of.
Would that include the frequency, or do we not need?
Don't worry about the frequency.
So what about T star? So
You don't need to write down T star.
We don't.
But you should be familiar with, again, think back to calculate those formulas. If they give you a multiple choice question with the formulas filled in, you want to have T star written down. Does that make sense?
Mm-hmm.
Like you need to know how to calculate T star. You don't necessarily need to write it down. Okay? Everybody feeling okay? All right. What do you think we should do next? Make our conclusion. Does anybody want to guess what the start of our conclusion is going to be?
We are 90% confident.
We are 90% confident at the interval from 276.28 to 304.72 contains
Would be the true value of the mean. I don't know.
the true
That's what we call it.
mean of all screens. On what I would do from here is just copy the verbiage from the question. The true mean tension of all screens produced this day. What do you guys think? Is this okay? Am I right in that this unit 7 is not as bad as unit 6? Because like I don't need to explain to you what 90% confident means anymore, right? That doesn't mean it means the same thing as it always has. 90% of the samples we take will give us an interval that contains the actual value. Okay? What do you guys think? You ready to try another one? Don't get annoyed that you have to sketch this graph. It's only going to be a small amount of dots if you have to sketch the graph. Okay? All right. What should I do? In this case, we're doing a 1 sample t interval for mu.
And then we need to define what mu is, right?
So what is mu? It's the true mean nitrous oxide rating. Okay? Random.
Given random sample.
We were given this as a random sample. Normal.
It says 40, so it's
Our sample size, there's 40 engines in this sample, and 40 is in fact greater than or equal to 30. We're all set. We don't need it. We don't need to draw the graph in this case because we don't need to draw the graph in this case. Okay, like now if I draw this, well, it's gonna be hard to draw the graph also when we don't have the raw data. It'd be pretty impossible. Not to mention annoying. So one of the things I want to point out is sketching a dot plot can be annoying when you have a large sample, right? Like, but if it's a large sample, you know. All right, independent.
less than 10%.
Of light duty engines. Is that how they're described? Light duty. Cool. Now what? What do we have to do next? Is there anything left in box 1?
No.
Nope. So we go up to our calculations, right? So from here, I would say let's go ahead and put this in the test menu, okay? And as we go through, so go ahead and hit stat, arrow over to test, option 8, t interval. And as your calculator asks you for things, now, do we have the raw data this time? No, we have the summary stats. So go ahead and highlight stats this time instead of data. And notice that your calculator is starting to ask you things. Okay, what's the first thing it asks you for?
X bar.
X bar. If you need to tell it to the calculator, you need to write it down. So in this case, X bar is 1.2675. You guys with me? And then the next thing it asks you for is S, yes? S is 0.3332. So it asks you for N, 40. It asks you for the confidence level.
95.
In this case, you're going to put 0.95. We show that 95% confidence in our interpretation, like at the end, so that would be sufficient. But it's not like it's going to hurt you to write down 95% confident, okay? Do you guys see that this doesn't have to be bad? And then what are you guys getting?
1.1609 to 1.3741.
See? You guys feeling okay? You guys want to take a crack at the interpretation? I'm going to top off my coffee while you interpret. Okay, we are 95% confident. The interval. Your calculator basically found it for you to create this. So I wanted to show you guys how to do it by hand because sometimes in particular, like on the AP exam, they'll give you a multiple choice question where they won't give you the interval. They'll instead show the formula to find it, like with the different numbers filled in. And so you still need to know how to calculate T-star without it being.
So if you wanted us to like show it by like the calculations, you'd like specify that in the question.
Yeah. Well, more likely is what's going to happen is when you might come across a multiple choice question with it filled in, and you're gonna be like, where the heck did this number come from? It came from that T-star calculation. Okay. Now, so the EPA says that it's a limit of 1 gram per mile. Are we convinced that this has a mean nitrous oxide level of 1 or less? No, because the entire interval is greater than 1, yeah? All right, question. I'd like you guys to go back and look at your interpretation. And I want you guys to think through what is the verb tense. So we're going back to like, I don't know, English class. What tense did you write your interpretation in? It needs to be present or future. It cannot be past tense. Okay, we always like, with all interpretations, we want to avoid past tense because past tense usually means you're talking about the sample and not the population. Okay, and our conclusion is what conclusion we're making from our sample, but it's about the population. Okay? What do you guys think so far? T intervals, are they hard? The tiniest twist? Can I give you guys the tiniest twist? Okay. Do you guys remember talking about match pairs experimental designs? I mean, we did, right? Can we at least acknowledge that we remember talking about them? We don't need to remember what they are. But they were a type of experimental design.
Very much.
Is that the one with like two people were like assigned the same, like each had a different condition, but they were like compared to each other?
So that was actually a randomized block design, okay? A match pairs design was more like one subject got both treatments.
Yeah.
Or like a twin study is usually a match pairs. Like there's something that pairs those points to each other, okay? Dot, dot, dot. There's lots of ways I could do it. Imagine I was testing a new fertilizer. I might put, I might have like a pot with two plants in it, right? One getting like a spray fertilizer and one not, or something. Do you guys see what I'm saying there? Okay, so anything that pairs the 2 points together. And so I want you guys to imagine, okay? Ms. Meister's testing a new statistics plan for teaching kids, okay? And so one way I might practice this new plan is I might take my 2 statistics class, first period and 8th period, flip a coin, one of them gets the old plan, one of them gets the new plan. That is not a match pairs design. And in order to I can still make that comparison, but maybe what I do is I find the mean of first period and I find the mean of second period and I compare the 2 means to each other. Is everybody with me? Okay. What if instead what I decided was I was going to have half of each kid in the room try taking a test one way versus taking a test the other way? So now what I'm going to do, SOCI has 2 test scores, one for plan A and one for plan B. So now I don't need to compare the group to each other. I can compare SOCI to SOCI. Do you guys see what I'm saying there? Okay, that is what we call paired data. It's when we compare individual observations to a partner. Usually from a match pairs design, but not always, right? If I did a, so let's say I wanted to decide from the beginning of the year to the end of the year, did you guys improve in your statistical knowledge? So I gave you a pre-test and a post-test. That is not an experiment, right? I'm not randomly assigning you to the pre-test or the post-test or whatever. Do you guys see what I'm saying there? So it's not an experiment, so it's not a match pairs design, but it is still paired data. Okay? And so there is technically a new procedure called a paired T interval. It's very similar to a one sample T interval. So, let's pretend I did in fact give each of you guys a pre-test and a post-test. And these are your scores. As you look at these, what do you think?
What is, like, what's the range?
Yeah, how did someone get a 6?
Or like a 7? Oh, a 7.
Oh, I don't know. I made up the data.
Oh, okay.
Just in general, when you look at this,
Yeah.
how did Mrs. Meister do at teaching?
I think everyone improved.
If you had to quantify the improvement, if I wanted to estimate on average what people improved by, what should we do with each of these numbers?
Subtract the post from, sorry, pre from the post.
So we're going to come up with a quick calculation. I'm sure you guys can handle this, of post minus pretest. Okay? And what do you notice about all of these numbers?
All of them positive.
They're all positive, which suggests that every student improved at least a little bit. Some a lot, some a little. Okay.
Sister, why for the second one did you get 1?
I didn't get one, you got one. I got 3. Hey guys, I would really, really appreciate it if you don't tell anyone that Miss Meister screwed up doing 1 minus 0. It would really go well for my ego, because if like Richards or Lombardi heard that, I'd get made fun of a lot. No, really, 3 minus 0 should not be that hard, right? I just screwed up the way I said it again, didn't I?
Yeah.
Ay, Dios mío. All right. Now what? Let's do that. Are you guys cool if instead of calling this a paired T interval or a one sample T interval, we're going to call this a paired T interval. Now, guess what? If you screw that up and you put 1 sample, I'm not going to ding you. Okay? It is technically a paired. The other thing we're going to do is we're going to call this 4 mu D. Anybody want to guess what that D stands for? Difference. Mu D is equal to the true mean difference in test score. And as with any difference you guys do for me, you should state the direction of that difference. So post minus pre. Now, what if you guys all looked at this and said, I'm going to do top row minus bottom row, and did 0 minus 2, 0 minus 3, 1 minus 2? We're going to get the exact same interval. It's just going to be negative. And then obviously flipped, right? Because the smaller number goes first. But like it's the interpretation of that next piece that would make that doable. Okay. Next. What should I do next? Random, normal, independent, yeah? Talk to me about the random.
Given random.
We were given this as a random sample. Okay. Normal.
We need to apply it.
When we say it,
Well, the difference.
we have 3 different set of numbers.
Yeah.
The one we're performing the procedure on is the differences, so we need to make the graph of the differences. Okay? And when we look at that graph, there's no point in graphing it without talking about what we're looking for. What are we looking for on that graph?
No outliers or like.
I don't see any major skewness in their sample. Independent?
15 is less than 20% for a week.
It's
Yeah, we're going to pretend it's true, okay? It's definitely not true. This is one of the lowest class loads I've ever had. But let's pretend, okay? All right? Next.
calculation.
Calculations. In this case, we have to type these into our list. Stat edit.
Do the differences.
You do the differences, yep.
Because I remember seeing like a 2-interval thing on there. So.
There will be. We're not there yet. The 2 sample t interval is when you don't have paired data. So that would be like, for instance, finding the mean of first period, finding the mean of second period and separately. Or finding your average number of tries before the New York Times took over the Wordle. And finding your mean number of tries after the New York Times took over the Wordle.
Okay.
It would have been good.
That would have been good. I don't know though.
Neither do I. I didn't keep track.
Mine, well, I had like 9 3s before it, and now I have like 9 5s. So clearly
Clearly.
there is a correlation.
I feel like I have failed you as a probability teacher of understanding randomness.
Well, so you're saying that it could have just happened.
I think.
Well, I don't think that's the case.
I understand. I understand what you think and what I think is different. I wish we had more raw data. I do think I should contact the New York Times and see if they'd be willing to release the data. I'm going to be like, as an avid fan of your crossword puzzle, I've done it every day for the past 3 years. I pay for your app. Could you please release this data to me? All right, so I'm going to hit stat, test, t-interval. I'm doing it from the data on L1, We're doing 0.95. Is everybody with me? So I just typed into my calculator and I got the interval to be from 2.585 to 3.682. Also, x bar was equal to 3.133. S was 0.990.
We need to put n also, right?
N equals 15. Everybody good? So the only main difference in the interpretation is going to be we are 95% confident. The interval from 2.589 to 3.682 captures, if you put contains, it's fine, the true mean and if we're going to do that, we need to make sure we do, like, for instance, post-test minus pre-test. What do you guys think? And did people improve? And how do we know that? The entire interval is positive. See, I told you, were paired t-tests really that much harder? All right, so here's the review. Why don't you do that and see? 2 kids yesterday did it and it worked just fine.
Yeah.
So here's what I'd like you guys to do, and obviously if you want to take a break, you're certainly more than welcome to do so. Do the review. That should be your first priority. You will have a quiz tomorrow. I know it's supposed to be a no homework night. I promise you, the quiz is not longer than this. We can spend the first 15, 20 minutes studying if you guys want. So you shouldn't stress it. It's an 8-point quiz. It will not affect your grades. The other thing, if you have not finished test corrections, you could use this time to also work on test corrections. I think most of you have them in. We can chat. What else? That's what I got. After you're done with those, progress check, please, and thank you. And just a reminder, my job is to be helpful to you in any sort of way as you now interact with this content. But I believe in all of you very, very much. Go get it.